All right, so here we go. This is chemical reactions part 2. Hopefully you recall last time we went through a couple questions. So I have those questions here and we'll just make sure that we understand them. And so we talked about what happens during a chemical reaction, and that would be that the atoms are interacting with each other. They rearrange to form new substances. So we talked about that. We talked about how can we describe the chemical reaction. So with this, what we're looking at is we write down the chemical formulas of those things that are reactants, and we write down the things that are the products. How did they rearrange and become new things? Then, to make sure we have not violated the law of conservation of mass, we balance the equation. So if you still don't remember how to balance equations, that's kind of the important part. That's what we're going to talk about here in just a moment. The other two things we'll talk about in this video are the other two questions. What evidence do we have of a chemical reaction? And are there any patterns we can look at so that we might be able to predict a chemical reaction before we even know what's happening? We just know what the reactants are. Are there patterns to help us know the products? And there are, and we'll talk about those. So as we get started, the first thing is to review this thing called balancing equations. The one thing you need to recall is you cannot create or destroy atoms. It doesn't matter what's going on. The number of atoms of every element must be the same, both as reactants as products. They might rearrange and you have a substance like a diatomic molecule of oxygen that's O2, but when it reacts it forms another product, and now you have like carbonate. CO3 is one of the products. So the O2 and the O3, like not every time that you have that element does it have to have the little 2. Chlorine is another example. You have chlorine as a gas that is Cl2, but when it forms sodium chloride salt, it's NaCl. So don't get stuck on the whole diatomic thing. You just need to remember which ones are diatomic. So you can't create or destroy atoms. You also can't change the chemical formula of whatever that thing is. If I have calcium carbonate would be CaCO3. When I go to balance the equation, if I need more than one of these things, I can't just say, oh, I need calcium to have a 2, so I'm going to put a little 2 right there. That changes the entire compound. That is impossible. You can't do it. Don't do it. It's wrong. The only thing we can change is the coefficient that goes in front, and I believe that's the last thing. Change the coefficients that are in front of the chemical formula. By changing the coefficients, you are multiplying that substance, and you end up with multiple atoms, and you make sure that it's balanced on both sides of our equation. So like I wrote right here, let's do some real fast just to practice. All right? So the first one is this KCl plus O2 forming KClO3. So the other thing is sometimes the format of the font that we're using confuses some of you. This is not a number 1. This is an L. This is KCl, potassium chloride. Shut up. See, that's why I tried to do this after school, so there wasn't interruptions. KCl plus O2. So oxygen gas is reacting with this thing called potassium chloride. When we react them together, we form this stuff called potassium chloride. So in order to balance the equation, there's different strategies you can use. You can list out all of the different elements on both sides of the equation and then multiply and add and write them down until you have matching numbers. For me and for many of you, as you start to get better at this, you won't need to do that. Here's what you do. I have a K on the left. I have a K on the right. That's good. I have a Cl on the left. I have a Cl on the right. That's good. I have 2 oxygens on the left, but I have 3 oxygens on the right. We have a problem. I must balance those oxygens, but not mess up everything else. And as you start to look at this, you're like, well, how about, what's going to happen there? Anything I do to KClO3, I'm going to have to do to KCl because they have the same chemicals with them. So if I multiply this by 2 in order to get 6 oxygens, then I need to multiply this by 3 to get 6 oxygens. But it also multiplies the KCl by 2. And so our balanced equation is 2 KCl plus 3 O2 forms 2 KClO3s. Right? The lowest whole number ratio is what you have to do. You can't use 1, 1 and 1/2, and 1. Even though that's balanced, it's not properly balanced. You must use the lowest whole number ratio. So here's another one. Potassium, if you drop it into water, it produces hydrogen gas and potassium hydroxide. So in order to balance this, again, I typically would say start from the left and work from left to right, balancing one element at a time. Once you modify something, then go back and fix it. So here I have a K, here I have a K. K is okay right now, but it won't be for long. Here's 2 H's. There's 2 H's here, but there's also an H in this compound. So I have 3 H's on the right, but only 2 H's on the left. So in order to balance this, we got to figure out, okay, I can never make an even number become an odd number. So these two, I have 2 here, that's always going to remain even, and I have 1 there, that's always going to remain, that's not going to remain, that's 1. So if I multiply that by 2, now I have 4 hydrogens. What happens if I multiply this by 2? Well, that gives me 4 hydrogens. Notice that this 2 also modified the oxygen. So this 2 modifies that oxygen. We have 2 oxygens, 4 hydrogens, 1, 2, 3, 4 hydrogens, so that's good. And now we have 2 Ks, so I need 2 Ks. And people look at this and go, well, what happened? They're all the same number, but they're not. Technically, what's happening right there? That hydrogen has been balanced with a 1. When we write them on paper, we do not use the number 1, but when we do it on a piece of, on Moodle or on a computer, you need to make sure that you put a positive value of the 1 there. Another one, C4H10 plus O2 forming CO2 and H2O. This is what we call a burning of butane. This is like when you light the Bunsen burners with the lighters. This is the fuel that's inside that. So we have this C4H10, O2, CO2, definitely not balanced in terms of anything, right? So let's start with the carbons. 4 carbons there. We'll put a 4 here. 10 hydrogens. There's 2 hydrogens here, so let's put a 5. And now oxygens, there's 2 here, but we have 8 plus 5. That's 13. What times 2 equals 13? If you say nothing, you're wrong. I'm going to punch you. There's actually something we can do, right? 13 halves would be 13. 13 halves times 2 would be 13, and that gives us our 13. Well, remember I said a few minutes ago, you can do that to balance it, but it's not properly balanced. Now I need to get rid of this fraction. I need to get rid of the decimal by multiplying everything in order to make it balanced. To get rid of this, essentially all we do is double everything. So I'm going to double this. I need to make that bigger. We're going to double this to 13. That makes this a 2. This becomes an 8. And then this one, 5 times 2, is 10. And now let's make sure that it's still balanced. I have 8 carbons. 2 times C4. I have 8 carbons. I have 20 hydrogens. I have 10 times 2, that's 20 hydrogens. And I have 26 oxygens. Here I have 16 plus 10, that's 26 oxygens. Notice that there's no way for me to reduce these coefficients any lower. I can't divide everything by 2. I have a balanced equation with 2, 13, 8, and 10. Last one to do is here. NH3 plus O2 forming NO and H2O. We're going to use the same idea. Remember in one of the videos that you watched during the stations, it said to, hold on, my screen's telling me something. Oh, that's not good. I think I'm going to run out of storage on my video. We'll see what happens. I'll keep going and see if it stops. It says save hydrogen and oxygen for last. So let's do that. In, we're good. Now we got to balance everything else. 3 hydrogens, 2 hydrogens. So if I make this a 2 and this a 3, that makes both of those 6. Now I have 2 nitrogens, so I need a 2 nitrogens. That makes that balanced again. But now I have 2 and 3, that's 5 oxygens. 2 times what equals 5? Don't say nothing. It's 5 halves. This is technically balanced, but it's not properly balanced. So just double everything. This becomes 4, this becomes 5, this becomes 4, this becomes 6, and we're balanced. Sound reasonable? Okay. So now, as we move on, the other things that you need to be aware of, it looks like my video, it's telling me that I've got to quit because it's about to stop. So I'm going to pause. We're going to have 2 sets of video for part 2 today. There's the first one.